In this question, it is given that the vertices of a hyperbola HR plus minus 6 comma 0 and its eccentricity is root 5 by 2. Let n be the normal to hyperbola H at a point in the first quadrant and parallel to the line this. If D is the length of the line segment of n between H and the y-axis, then D square is equal to dash. You have to fill in the blank. According to question, this is a hyperbola with this 6 and this minus 6, and the name of this hyperbola is H, and this is a normal n to the hyperbola H at a point in first quadrant. The name of this normal is n. And this normal is parallel to this line. That is, this is a line to which this normal is parallel, and the equation of this line is root 2x plus y equal to 2 root 2. And the length of the line segment between y-axis and the hyperbola, that is this length, is given to you as d. Then d square you have to find. And because we know that b square is equal to a square into e square minus 1 for any hyperbola, and a is 6 given to you, e is root 5 by 2 given to you, hence we get b square equal to 36 into 5 by 4 minus 1, that is b square is equal to 9. Hence the equation of hyperbola becomes x square upon 36 plus y square upon 9 equal to 1. That is, a is 6 and b is 3. And let this point say a as a sec theta, b tan theta. That is 6 sec theta, comma 3 tan theta. And we know that for the hyperbola x square upon a square minus y square upon b square equal to 1, equation of normal at any point x1 y1 is given by the formula a square x upon x1 plus b square y upon y1 equal to a square plus b square. And now using this formula, equation of normal at the point A becomes 36 x upon 6 sec theta plus 9 y upon 3 tan theta equal to 36 plus 9. That is, I get 6x cos theta plus 3y cot theta equal to 45. That is 2x cos theta plus y cot theta equal to 15. And clearly the slope of this is minus 2 cos theta upon cot theta. This is equal to, because this normal is parallel to this line and the slope of this line is minus root 2, hence we will put it equal to minus root 2. That is, I will get sin theta equal to 1 by root 2. And because this point lies in first quadrant, hence I can say theta equal to pi by 4. Hence clearly this point becomes 6 sec theta. That is 6 root 2 comma 3, and this point has x coordinate 0, and to find the y coordinate of this point, putting x equal 0, the value of y becomes 0, 15 tan theta, and because theta is pi by 4, therefore this point becomes 0, 15. Hence I can say d is equal to under root 6 root 2 minus 0 whole square plus 3 minus 15 whole square equal to 72 plus 144 equal to under root 216, that is d square becomes 216. Hence the answer to this question is 216.